Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 23, 2026, just 3 days ago. It introduces a massive 560 billion parameter mixture of experts model that achieves state-of-the-art results among open-source models on agentic benchmarks, including a perfect score on the MoE 2025 math evaluation. The paper is titled LongCat Flash Thinking 2601 Technical Report. And, as we'll see later, the implications for building agents that can handle messy real-world tools are quite significant. Figure 1 details the model's performance across 4 key domains: code, math, tool use, and search. If you look at the top right panel for math with Python, you see the confirmation of that perfect score, where the striped green bar for heavy thinking mode, which scales up reasoning effort at test time, hits 100 on MoE 25. Moving to the bottom row, the benchmarks for agentic tool use and search demonstrate that this open-source model rivals even closed-source giants, like GPT 5.2. Well, to see what drives these gains, Figure 2 isolates the impact of the team's new mid-training strategy. The charts compare the old baseline in gray against the enhanced model in green across 3 agentic domains: airline, retail, and telecom. The metric here is pass at K, which measures how likely the model is to succeed given K attempts. Notice how the green line consistently dominates the gray one, especially in the telecom sector on the right, where the enhanced model is dramatically more effective at lower attempt counts. So while the previous figure highlighted mid-training gains, Table 1 evaluates the robustness of the reinforcement learning stage. It compares 3 setups: a cold start, training without noise, and the proposed method of training with noise. The critical test appears in the row for VitaBench noise, which simulates imperfect environments. Notice that standard training only scores 13.3 here, but adding noise during training boosts that significantly to 20.5. This confirms that exposing the model to simulated errors essentially immunizes it against the messiness of real-world interactions. Alright, Figure 10 unveils the architecture behind the heavy thinking mode responsible for the high math scores we saw in Figure 1. This framework splits the inference process into 2 distinct stages to maximize accuracy. First, on the left, the user query enters the system and triggers a thinking large language model. Instead of just generating one answer, it fans out into a parallel reasoning stage, creating multiple independent thought trajectories simultaneously. Then, moving right, a summary large language model acts as a judge. It reviews all those parallel attempts stored in context memory, synthesizes the correct reasoning, and produces a final, high-confidence output. Table 2 puts those heavy thinking claims to the test, comparing this new model against top-tier open and closed-source competitors. If you look at the far right column under mathematical reasoning, specifically the MoE 25 row, you see a split score of 99.6 and a perfect 100. That 100 is achieved using the heavy thinking mode we just saw, effectively matching the performance of proprietary giants like GPT 5.2. Lower down in the agentic tool using section, the model maintains this lead, scoring 88.2 on the Tau 2 benchmark average, which surpasses the open weight alternative shown on the left. Well, Figure 12 shifts the focus from raw reasoning power to computational efficiency. This comparison highlights the gains from the experimental zigzag architecture, which uses sparse attention to handle long contexts. In both the prefill chart on the left and the decode chart on the right, the baseline model sits flat at 1.0. However, the dark green line for the zigzag variant climbs significantly as the input size grows. By the time we reach a context length of 256,000 tokens, this sparse approach achieves a speedup of roughly 1.5 times, proving it can handle massive documents much faster than the standard model. Wrapping up, 2 takeaways stand out. First, training on simulated noise creates agents that actually survive the real world. Second, the heavy thinking mode proves that scaling inference time can unlock perfect reasoning capabilities. These innovations offer a powerful new foundation for open source autonomy. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.